Research.
Hey everybody, welcome back to GR Research, here with me, Danny Ritchie, and today we have a doozy. Today we're finally doing one that I've had in my head for quite some time. We're kind of going back to those Tuesday Tech Talk videos that I used to do. This is definitely one of those Tech Talk videos. I've been wanting to talk about this subject for a while. I want to try and educate you guys on this stuff a little bit and bring some truth out there to this subject. And of course we're talking about cables and the differences that there are in cables, and I've been thinking about this for, like I said, for quite some time, and I really wasn't sure how I wanted to go about it. I thought about maybe doing something where I bring you guys into my listening room and let you hear some differences between the cables that I could do some audio clips on, talk about the things I hear, but I just felt like it's just going to create more firestorm. You know, it's going to bring out the crazies, all the naysayers, all the guys who have a specific belief that they don't want to hear anything to the contrary of. And we know who those guys are. They're the first ones to cry snake oil anytime you start talking about the differences that there are between cables. And this video isn't designed to incite all those people. This video is specifically to educate you guys who have an open mind, who are willing to learn, who are willing to comprehend just some very basics. And I've come up with a way to illustrate that very well. And I think this is going to work much better than taking you into my listening room. And I also thought at one point maybe I should tackle this from an objective standpoint and really go into the science of it, talk about the differences in the purity of the copper, the differences in the dielectric material, and how those things interact with the signal and change the signal, and a lot of the stuff that are very specific and very technical. And I felt like I would just lose most of my audience doing that, and I'm still not going to convince anybody of anything until you can really see something and understand it and comprehend it. And I think I figured out a way that you guys can grasp this. So what I've come up with is a way to illustrate one of the many differences there are in cables that are clear, audible differences. I know I could go all the way into the quality of the copper and talk a lot about the dielectric material and how that affects it. Those are big differences in how a cable sounds. But this is also a pretty significant difference. And this one I can show you and I can illustrate it. And the way I'm going to do that is just with this little device right here. As some of you recognize, it's what we used to call a tuner. It's very much like what modern receivers are. It's just for receiving AM and FM information from your local radio stations. So what I've got here is a tuner, and we're just going to be looking at the signal strength indicator on the FM reception. And we're not hooking up an amplifier and hooking up speakers to it. We're not going to listen to it. If we played the actual radio through the video, I have no control over what is on the radio. And if there's music playing, YouTube's going to flag it. And I'm not supposed to rebroadcast all that information and stuff anyway. So we're not going to be listening to it. We're going to be zooming in on the view meter here. And it's a signal strength indicator. It shows how strong the signal is of the FM radio station that we've tuned into. And today we've tuned into a local channel. It's what's called The Bear on 104.7, where my buddy Keith Vaughn works. That's the one we're going to be using today. So hey out there, Keith, and all you guys out in the Wichita Falls area who listen to The Bear. What we've got is on the back of this, I've slid some little short pieces of wire into the back of it, into the FM antenna slot. And it's a solid core copper wire. It's just running up the back here. And then on that, we've got some alligator clips clipped onto it with a little short piece of wire with some more alligator clips on here on the end that's going to allow me to clip different cables on there. And then we're going to get to watch as the meter moves and show us one of two things, because these things are very obvious, and it's, like I said, it's one of those huge things that determines how a cable sounds. And the cable can be one of two things or somewhere in between. It can either be an antenna or it can be a filter. or it can be somewhere in between. So, and this is any cable in your system, from the wall socket all the way to the speakers. Your cables can be picking up tons of radio frequency interference. It can be picking up tons of electromagnetic interference, or it can be filtering those things out of the signal. And the difference is pretty significant. I mean, very significant. Anybody that comes to my house and listens to my audio system within a few songs, one of their first observations is, I can't believe how quiet the noise floor is. It is dead quiet. I can hear everything. All the little details, the things that are going on within the intricacies of the music and the layering of that music. It's so obvious because the noise is all gone. So I've spent a lot of time from one end to the other, from the power to the computer to the DAC, everything low noise. And a lot of the systems off the grid. We're running on batteries. So it's a big deal. So when I drop in a cable, especially one that is very much an antenna, you can easily hear the noise. Easily. No question about it. Simple, easy to hear. We put in a different cable that is very much a filter. Opposite effect. Wow. Dead quiet. Noise floor. Now we're hearing the decay of the instruments. I've heard people say, wow, the decay just goes on and on. I can hear the decay of each instrument so clearly because it's not smeared and covered up by the noise that's on the lines that really affects the signal. So here's what we're going to do. I've got 4 cables here that we're going to drop onto this thing and let you guys see the difference in how much these things can be an antenna and how much they can be a filter. And then we'll talk about each one and how it's affecting the signal. So the first one is everybody's favorite out there who thinks cables really don't matter. This is just 12 gauge multi-stranded copper in a PVC jacket. You can get it anywhere. This is your cable that's pretty much like a zip cord. You can get it at Lowe's or Home Depot or wherever you want to get it. Cable number 1. Cable number 2 is very similar. It's a 16 gauge multi-stranded copper, and it is the same 2 pair, but it's twisted a little bit. So we got a twisted pair. And then the third cable, it's a silver coated copper cable. This cable is designed so that there's 3 different legs that are of each color, basically. So we've got a hot and a negative, a hot and negative, a hot and negative. How about there? A plus and minus, plus and minus, plus and minus. And then those 3 pairs are braided into a 3-wire braid. So there's some braiding going on here, some crisscrossing of the cables, and it's just like a little girl would braid her hair. It's like a 3-wire braid, but there's 6 cables. And then the last one we're going to look at is 24 strands of continuous cast copper in Teflon. And this one is a 24-wire braid technology. So they're all braided, and there's a poly cotton core running through the center of it that's helping separate that. And this is all designed to block and reject or filter all that RF noise and EMI. So we're going to pause the video here. I'm going to get on the other side of the camera. I'm going to readjust everything to where we can look at this meter. And then one by one I'm going to clip them on, and we're going to have a look at this and see what it does. Alright guys, let's see what happens. We're zoomed in on the meter there, as you can see. Hopefully the camera will stay focused on it and not move around with me. First one we're going to drop on, 12 gauge multi-stranded copper, PVC jacketed. We're on, and man, we pegged this thing out. +3 on the meter. Pretty good antenna. I'm not even holding it up. Sometimes if I grab it and wave it around a little bit, I can pick things up a little stronger, but this one seems to be doing pretty solid. How about that? It's a pretty good antenna. How about the second one here? 16 gauge multi-stranded copper. This one's got a little twist in it. Sometimes that helps things a little bit by putting them in twisted pairs. And the twisting does help a little bit. We're seeing about 2 5/8, a little 2 1/2 maybe. If I pick it up and move it around a little bit, oh yeah, we're getting up there now. A little over 3. How about that? That's the effect of the 16 gauge twisted pairs. Here we go now with the braided one. This is the 6-wire braid. Let's hook this baby on there and see what we got. Not much, man. Let's see, I can move it around a little bit here, wave it around in the room. Little inconsistency there, waving it around. I can get it up to 1.5, almost 2 there for a little bit, but it's rejecting a lot. Oh, there we go. It's picking up a little bit there. I think it's using me for a little bit of an antenna. Let's try the last one. This is out of my reference system here. This is the speaker cable that I use in my system. This is the 24 strand high purity copper, Ono continuous cast copper in Teflon, and we got nothing. I mean nothing. I'm going to wave this thing around, see if I can get it to pick up anything. Nothing. No FM reception at all. In fact, it's as bad as without it even being hooked up at all. We got nothing. That's what we get on the meter. Let's talk about it. Alright guys, one of the things I noticed as I was watching back the video clip on the measurements reminded me of when I was a kid. And any of you who are my age or older will remember when televisions had antennas on them, and they would have what's called a rabbit ear antenna. That would be just 2 antennas that stuck up, and you'd have to adjust those and move them around to try and pick up the television stations that you're watching. And depending on where you had those things twisted, determined how good the picture quality was. And Dad would come in and say, "Hey, adjust the antenna there for me. I'll tell you when you got it," you know. And I'm up there moving it around, and he'll say, "Yeah, that's it right there." And then I'll let go of it, and then, "Oh no, you lost it again," you know. And put your hands back on it again. "Oh yeah, that's great." "Okay, take your hands back." "Oh yeah, you lose it again." Just stand there with your hands on it, because the picture's great while you're holding it. That's because it's partially using me as an antenna. And this is doing the same thing. Whenever I'm switching this stuff in and out, at part of the time while I'm holding it, touching the chassis, things like that, it's partially using me as an antenna. So a couple of times there it may have blipped a little as I was putting stuff on and off. That's what's going on. So big things we noticed. These were the 2 big differences here. Your standard pair, which is very much an antenna, and these 2 speaker cables that we're showing, they're about the same length, 6-foot pairs. Let's recap again. I don't know if you can see it on the meter from there, but yeah, pretty big. We're way up there past 3 again. And when I was moving that around, I was waving it around up in the air, trying to make more, or trying to utilize it as a better antenna. Same thing with this one. This 12 or 24 braided cable, which is showing almost nothing. I'm waving it around in the air, trying to pick up something. Nothing. So what's going on here? Why is it doing what it's doing? And does it have an audible effect on what we're listening to? Well, this is very much what we used to use back in the day when we were kids. We'd put this on the back of our tuners or receivers, and we'd split it, and we'd run one split one way and one split the other. Would make a T. It's called a T-type antenna. So it'd go up the wall and split, and it worked great. And sometimes we would try to make a big one, and we'd run one leg over to the window screen and the other leg over to the other window screen, and we could use that then at night to pick up all the rock channels down in the Dallas area, which were 130 something miles away, and we could still pick them up plain as day. Back then it was not a problem. Today it'd be pretty hard to pick that stuff up. So this cable now, on the other hand, is in the braided geometry. What's going on here? It's kind of like what I illustrated a couple weeks ago when we looked at inductors and capacitors. And I told you guys that as current runs through the inductor, it doesn't run through it like a garden hose. It doesn't run in one end and around and out the other. It's alternating current. So it's doing this. So as one bit is going one direction, the current on the other part of the winding is coming back the other direction, and those cancel each other out. There's a cancellation effect happening there, and it cancels out the high frequencies. All those short wavelengths get canceled out when you're creating that inductance. The longer wavelengths pass right through. The speaker cable is doing something along those lines. When you got that crisscross braided geometry, some of those really high frequencies are arriving at each other out of phase, and they're canceling each other out versus transmitting it down the line. And I know a lot of you guys have already looked at this and think, well, all I got to do is use shielded cables. No. Shielded cables are not going to help the situation, because it's not just airborne. This stuff's already on the lines. This stuff is already on every power line out there. Those are all huge antennas. There's tons of noise that are on those lines besides just the 60 hertz sine wave that's bringing you power. And everything in your house, the wiring in your house, all kinds of things generating noise that's already on the system. And then your gear is generating noise. If you're using a computer as their source, those switching power supplies in your laptop generate a ton of noise. Some of the power supplies on your electronics, your receivers, all of those generate some noise. And a lot of those electronics have filters and things built in to try and reduce that and try and knock that out of it, but there's a lot there. And when your speaker cable's shielded, it's only going to keep it from picking up more stuff that's in the air. But the stuff that's already on the line, it's already on the line. It's not filtering it. It's just letting it pass right on through. So it's not doing anything about all the noise that's being generated by all the gear that's already on your electricity, all that stuff. It's already there on your system. That's a big difference from using a cable that is basically designed to become a filter. And this can happen again on all your cables, from power cables to the USB cables, your interconnects. All of that stuff can either transmit that noise or it can filter out that noise. So I'd like to go deeper into this, and maybe I will. Maybe I'll follow this up with some more. But for right now, I just want to leave that with you guys and at least give you something to hold on to and understand that there are measurable differences in these cables, and those measurable differences do equate to how it sounds. There's a big difference in noise floor when it's not there or it's heavy there. You want to hear a lot of it, just go to one of these audio shows where there's a hotel full of contaminated electrical noise all over the place, and it's everywhere, and you go in and listen to a system and you think, wow, that system it's really noisy. Especially when you're used to listening to a system like mine where there is no noise floor. You just immediately notice noisy. And there's really no excuse for that. It can really be removed easily. There are ways to do it. There are good quality cables out there, and cables can really make a difference. We just witnessed it today. Definitive, measurable proof that cables do measure different. And RFI and EMI rejection is a biggie. We just saw it. Don't know how much more to reiterate that. That's it for this week. You guys be sure and click the subscribe button right below, and there's a bell button there you can click also that'll help give you notification when we have a new video come out. Be sure and click all of those, and please repost this one all over the internet. Let all of those guys out there in the little flat earth areas that want to tell you that wire doesn't matter and that 16 gauge, 12 gauge, whatever is it. Throw it out there for those guys. They think it's just all about resistance. Resistance has very little to do with how a cable sounds. I mean, the differences in the resistance of these cables is in the millivolts or milliohms. Very little resistance difference, and it has nothing to do with how it sounds. Think of your speakers. Your speakers could be 4 ohm speakers or 8 ohm speakers. Huge difference in the resistance level of the speaker. Does that determine anything about how the speaker sounds? No. And neither does the speaker cable. The only time the gauge really becomes into play is when you are using some large subwoofers or something that really is demanding of current. You've got a big power supply, big amplifier on it. You're delivering a lot of power. When you're delivering a lot of power, you need to be able to flow a lot of current, and the gauge of the wire really starts to get a little bit more important. But as far as your standard speakers that most of you guys are using, you could use 16 gauge cable, for instance, and you're not restricting it any between 16 gauge and 14 or 12 gauge or 10 gauge. There's very minute differences there in the resistance, but that has nothing to do with how it sounds. There's a whole lot of things that contribute to how it sounds, and today we just watched one of them. So again, that's it for today. Thanks for watching. Let's make this one go viral, and see you guys next week.